Assalamu alaikum, dear friends and students. Today we will discuss the solution of the assignment based on hydrocarbons, molecular formula, molecular mass, structural formula, and line angle formula. So let us begin with the first question. Uh, in this question, we were given five molecular formulae and we were asked to encircle the hydrocarbons. So let us know what the hydrocarbons are. In fact, these are the compounds that contain only carbon and hydrogen. So if we have any other element other than carbon and hydrogen, so it is not a hydrocarbon anymore. So if you look at the compound 1, which is C6H12O6, although it's an organic compound, but it is not a hydrocarbon because we have the oxygen as well. However, compound 2, which is CH4, and yes, it is a hydrocarbon. And if you look at compound 3, again, because of the presence of chlorine, it is not a hydrocarbon. So as for compound 4, which has the nitrogen and oxygen along with the carbon and hydrogen, so it is also not a hydrocarbon. However, the compound 5 is a hydrocarbon because it exclusively contains carbon and hydrogen. So this was the first question of the assignment. Now let us discuss the second question. In this question, we were given six different structural formulae, and we were asked to note down to encircle the element which is not in the right valency. So before attempting this question, let us recall the valency of carbon is 4 and the valency of nitrogen is 3 and valency of oxygen is 2 and the hydrogen is 1. So now if you look at the compound 1, here the first carbon, it has the 3 valency being shown. It is three, the carbon has the 3 valency which is being shown here and which is certainly not the correct valency. So yes, this carbon is to be encircled because it does not have the 4 valency. However, the second carbon has all 4 valencies satisfied. So as the third carbon, one through the double bond and two through the single bonds, and the remaining two carbons are also in 4 valency. So as for nitrogen and hydrogen and oxygen. Now look at the compound B. Here the first carbon is in the correct valency with the 4 single bonds. However, if you look at the oxygen, which should be the divalent, that is, which should have the 2 valency, but here the 3 valencies of oxygen is being shown. So this is not in the correct mode of the valency, and the remaining elements, the carbon, nitrogen, and further carbon and chlorine and hydrogen, they all are in their correct valency. Now look at compound C. Here uh, we could see all carbons, the 6 carbons in the ring and the 2 carbons outside the ring, all are satisfied with their 4 valencies, whether through the 4 single bonds or through 1 double bond and 2 single bonds or through 1 triple bond and 1 single bond, whatever the case. However, the valency of carbon is satisfied. And so as for hydrogen, because hydrogen is monovalent, so all hydrogens are connected to carbon. So there is no atom in this compound C which is in the incorrect mode of valency. So if you look at compound D, and yes, the first nitrogen element, which is nitrogen, is being shown here with the 4 valencies, and yes, certainly it is in the incorrect mode. Uh, However, the 3 carbons and the oxygen and the hydrogens, they have their right valency. Now let's see the compound E. Here, if you look at the first carbon, it is in the correct mode. The second carbon is also in the correct mode of the valency. So as the third carbon, fourth, fifth, sixth, and seventh. So here no element appears to be in the incorrect mode of the valency. Now, if you look at the compound F, which is the last structure of this question, again here the carbon, the first, second, and third carbon, and also the fourth carbon, they all are in the correct mode of the valency. So as for nitrogen, which should be the trivalent and which is the trivalent, and all hydrogens are also in the correct mode of valency, being the monovalent. However, the oxygen should be the divalent, but here it is being shown the monovalent. So one valency of oxygen is missing. So this oxygen is in incorrect mode of valency. So this was the question number 2. Now let us discuss the question number 3. In this question, we were given 4 expanded structural formulae, and we were asked to simply draw their line angle formula. So basically, line angle formula is the compact form of the structural formula, expanded structural formula. In the line angle formula, basically we do not show the carbons, rather we draw a zigzag line representing a chain of carbon and with the appropriate number of hydrogens. So let's discuss the first case, the compound A. Uh, we have to draw the line angle formula of this compound. Now the trick is just to focus the carbon at the moment 1, 2, 3, 4, 5, 6, and 7. There are 7 carbons, so it should be drawn like this zigzag line which has the 7 vertices. If you count 1, 2, 3, 4, 5, 6, and 7, and remember each vertex represents a carbon with appropriate number of hydrogens. Uh, but wait, we have to put the 2 double bonds here between these 2 carbons and these 2 carbons. So when we draw the 2 double bonds, we may eliminate the first structure, which was incomplete. But again, it is still incomplete because we have to show the carbon double bond nitrogen and then a CH3 here. So if you consider here, now it seems to be the complete structure because C double bond N and this vertex represents a carbon. Now, what I was trying to say is that in the line angle formula, carbon is not shown. However, the heteroatoms are shown here. Nitrogen is the only heteroatom present which is being shown here, and hydrogens are also not shown, but hydrogens are assumed to be present. For instance, in this terminal carbon which is connected to this carbon must have the 3 hydrogens attached to this carbon because of the satisfaction of the 4 valencies of the carbon. However, if you look at the second carbon, this carbon, it is directly connected to this right-handed carbon and this left-handed carbon. So 2 valencies are satisfied with the carbons, but the 2 valencies are remaining, which should be satisfied with the hydrogens which are hidden. And for the third carbon, there should not be any hydrogen attached because this carbon is singly bonded to this carbon and singly bonded to this carbon and doubly bonded to this nitrogen. So all 4 valencies are satisfied by non-hydrogens. But here we could draw this line angle formula with the correct stereochemistry, because if you look at these 2 carbons which is in the double bond, the 2 hydrogens are on the same side, but in this picture we have shown the hydrogen here and the other hydrogen is upside and the one hydrogen is downwards. So this is not in the correct stereochemistry. But if we redraw this molecule like this, and now it is in the accordance with this given structural formula, because in doing so we have placed the 2 hydrogens on the same side, although the hydrogens are not being shown, but we know that the hydrogens are here, which we do not show in the line angle formula. And by the way, this configuration is called cis and this configuration is called trans, which we will discuss in some other assignments. Now let's discuss the structural formula B. Again, let's start by drawing the zigzag line, and this time let's consider this oxygen also. So 1, 2, 3, 4, 5, and this nitrogen to be the 6th atom, 7 and 8. So first of all, we have made this 8 atom zigzag line. Let's count again: 1, 2, 3, 4, 5, 6, 7 and 8. I will tell you why I have drawn the hydrogen here after a little time. uh, Here I would like to add one concept, that in the line angle formula, as mentioned, the hydrogens are not being shown which are attached to carbon, but the hydrogens which are being attached with the heteroatoms, they are to be shown. And remember, the heteroatom means any atom other than carbon and hydrogen. So hydrogen with the oxygen and hydrogen with the nitrogen should be shown here. And this hydrogen which is attached to carbon is an exception to be shown here, because this is the aldehydic hydrogen, and by convention aldehydic hydrogen is also shown, although if we do not want to show, still it may be assumed that hydrogen is here, but by convention we have to show the aldehydic hydrogen. So this is the zigzag line. But now let's put the substituents here. For instance, we have the bromo here after this carbonyl, so the bromo should be here, and we should have this CH2 and CH3, that is called ethyl group, at the alpha position of this carbonyl. With alpha I mean the carbon adjacent to this carbonyl, and in fact we have this complete structural formula now, which is in the line angle form. This is the answer for this compound B. Now let's discuss molecular formula, structure formula of C, compound C. Again, let's count the atoms: 1, 2, 3, 4, 5, 6, 7, and 8. 8, 9, and 10. Sorry, the 10 elements which are being shown in the zigzag fashion. This CH3 is this terminal carbon, and this oxygen is between the two carbons, and then we have the CH2 here, and another CH2. In fact, this is not the CH2. In the other structure, we will add the substituents to this carbon. So let's directly discuss this structural formula. We have this OH here, which is the part of this carbon, and then we have the carbonyl, and then we have CH2, then we have CH, which is connected with the CH3, which is called the methyl, which is here, and then this NH connected to this C, and which is connected to this chlorine at one side, and CHO, that is the aldehyde group, on the other side. So this is the line angle formula for compound C. Now let's discuss the line angle formula for compound D. Here, if you count the carbons and the oxygen in the linear fashion, the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is also the 15 atom chain, which is in zigzag fashion. And remember, one thing I would like to add before putting the rings, uh, all carbons are in zigzag fashion, but this carbon is shown in the linear fashion because of this uh, mode of hybridization, which is sp, and we know that the sp hybridized carbon is linear, so we cannot bend this triple bond like we bend the other atoms, other bonds. And after this carbonyl we have this six membered ring. So this is in fact the structure, not the first one. But first one was the incomplete structure. Now this is the complete structure. We may eliminate the first structure. So if you look at this line angle formula, it corresponds to this expanded structure formula, because this is the benzene structure. After benzene we have CH2, then we have C double bond C, and surely it must be attached with the hydrogens, and then we have a five membered oxygen containing ring. This is the oxygen which is shown here, and then we have C triple bond CH, but as discussed we do not show the hydrogen, so we simply drew the C, the triple bonded line, which means that the carbon is here and another carbon is here with the hydrogen here, and no hydrogen here, because we have already four valency satisfied with one single bonded carbon and one triple bonded carbon. So you could see how beautiful and compact this structure seems when we draw in the line angle formula, uh, rather than drawing in the expanded structure formula. Now let's discuss the fourth question. It simply asks to draw the molecular formula and the molecular mass of these three molecules. The mass numbers of the atoms are given. So now let's discuss case by case. The first structure is being shown on the screen. So what should be its molecular formula? Basically, it's a practice. It's a practice of the line angle formula, that whether you are able to deduce the information from the line angle formula or not. So if you count the number of carbons, so this is the carbon and this is another carbon. So two carbons, three carbon, four, five, six, and seven carbons. So we have seven carbons. So to write the molecular formula, first we have to write the number of carbons, and then we have to count the number of hydrogens. So if you count, this is CH3. So it has three hydrogens. It has two hydrogens. And why two? Because this is attached with oxygen and carbon. So 3 plus 2 is 5, and then no hydrogen, and we have one hydrogen, so 6, and then 3 9, and 3 12. There is no hydrogen here because it is bonded to two single bonded carbon and one double bonded carbon. So overall we have 12 hydrogens, and now we have two oxygens which are very clearly shown here. So this is the molecular formula. Here I would like to add one thing very important, which we will also discuss in the other two structures as well, that to write the molecular formula, there is a convention that the carbon is written first and then the hydrogen, and this is the sequence, and then we write the heteroatoms, that is atom other than carbon and hydrogen, in alphabetical order. Here it was only one element, so there is no competition or issue of the alphabetization, but in other example we will again come to this case. Now let's discuss the molecular mass. It is very simple. We have seven carbons, so we multiply this 7 with the atomic mass of this carbon, which is 12. Then we add these 12 hydrogens into one, which is the atomic mass of hydrogen. Then we add 2 into 16. 16 is the atomic mass of oxygen, and 2 is the number of oxygens here. So when we multiply these three products and then we add, we get 128 to be the molecular mass for this particular compound A. Now let's discuss the compound B. Again here, first let us count the number of carbons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have 11 carbons. And here remember, one mistake that could be made is not to locate this carbon. Usually we only consider the carbon which is in the zigzag fashion, but for the triple bond we have to very carefully consider these two carbons as well, because we cannot bend this bond because of its linear geometry, but the carbon is here. Now let's count the number of hydrogens: 3, 4, 7, 8, 9, 11, 12, 15, and 16 because of this OH. Now let us discuss, we have discussed the number of carbons and hydrogens. Now what is left? The nitrogen, oxygen, and fluorine. So three heteroatoms, and we will have to write these three heteroatoms in alphabetical order, and we know that fluorine comes prior to nitrogen, which comes prior to oxygen. So we have FnO3 because one fluorine, one nitrogen, and three oxygens. So this is the case which we were discussing, that we have to write the molecular formula with the alphabetical order for the heteroatoms after the carbon and hydrogen. Now let's discuss its molecular mass. 11 carbons to be multiplied with the mass number of a carbon, which is 12. Then we have to add 16 into 1. 16 is the number of hydrogens and 1 is the atomic mass of the hydrogen. Then we have 1 for one number of fluorine, and 19 is the atomic mass of fluorine. Then we add 1 into 14 because of nitrogen's atomic mass, and then 3 into 16 because of 16 is the atomic mass of oxygen. So when we multiply these numbers and add, we get the sum of 229, which is the molecular mass of this compound. Now let's discuss the compound C. Uh, let's see whether we are able to count the number of carbons or not. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these are the 12 carbons which are here in this molecule. Again, we may skip this carbon or this carbon because of the triple bond, but do not skip. We have to count, and so as the case for this carbon, which is C triple bond N. Now let's count the number of hydrogens. One hydrogen is here, no hydrogen is here, zero hydrogen, one hydrogen is here. So it makes 2, and 2, 4, and 2, 6, and 2, 8, no hydrogen, 9, 10. So overall we have only 10 hydrogens in this molecule because there are many carbons which are hydrogenless. For instance, this carbon and this carbon, this carbon and this carbon. Now there are two nitrogens as well. So the molecular mass must be 12 into 12 plus 10 into 1 plus 2 into 14, which makes the sum of 182. So we have deliberately not shown the unit of the molecular mass, which is the AMU, atomic mass unit, or the gram per mole, because we were not asked to write the unit. So we better simply avoided to write the unit, and we just got stuck to the magnitude. So that's all for this assignment. Thank you.